Okay, so I want to use here, assuming you have a project here and you needed to get elevation. I think this is around Ekiti State or so. And there is a project here or a work you need to do here, and you're expected to have an elevation. All things being equal, if you want to get the topography of a place, to as in approximately know how it looks. So in Google Earth, you can always come here and then click on part here. You can see here
Parts.
add, yeah, add parts. And when you click on add parts like this, let me assume you name it anything of your choice, and then you come up with these tools and click from here to here to here, and let me assume you click here. Now if you click OK, you will have that particular Ekiti that I put down as name here. So if I want to see elevation, I will always right click and say show elevation profile here. So if you click on it like this, you can see the elevation profile like this. So if you move your cursor across it, you can see the percentage change. As you can see, it sliding across the line and how high the elevation is
Sorry,
like
sir.
this.
Click on show elevation.
Yeah, so let me close it up again. I've
To
drawn
show
this
elevation.
line across here. I'll go to the left hand side where we have this temporal file, and then right click and say show elevation profile.
Okay, sir.
Now it will come up like this, and you can see between here this 0.4 at 0 meter,
Mm-hmm.
and the elevation is 469 meters.
Okay.
So if I'm not clicking, I am just moving my mouse across this line. You see here that it have shown you that the elevation minimum and maximum is, you can see this here, and if you see here, you see that it is 469, and then here it is 620 62. So as I'm moving this across it, you can see the particular location where this red line is pointing. It's where it is talking about. You see the change in elevation. It right now it is start reducing. If you look here, you see that we have 42 now, 543. Just be looking at here, we have this. So if you look here, you see this is like here 544. Now it is reducing down a bit, it's now coming down. So the elevation is reducing by 9%. You keep on coming down, you keep on coming down, you keep on reducing, and you can see it is changing dynamically. So with this, you can always have the feel of how the elevation profile, how it goes. As you can see, it's rising up again to 70 to 85 to 90. You can see the kind of elevation. So this goes in here, and this is about 1.2 kilometers. If you look there, you will see that the kilometers is increasing down to the last part of it. The last side of it is 1.37 kilometers with the elevation of 646. So with this, you can have a feel of elevation data. Is that okay?
Okay, sir.
Yeah, so this is a way, like approximately you want to know how the elevation goes here. This is the best way you can get it done. Even if it is on this road, you can plot the road and see the profile of this particular road by the same thing you did here. So if I want to do the same thing, I can now, like, I can now remove it like this. See the way I'm removing it, the way the plot is changing. So if I want to see the elevation of this road, I can approximately draw the line across
What
the
of
center line of this road. Okay?
the coordinates, like the nodding on the sea?
Yeah, we're coming to that. I just wanted you to see, like, profile. We go to the coordinate. Now if you look here, and if I click OK and return down to here, you see now this is the way this road, this is the profile of this road.
Okay.
So you have the approximately feel of how this road is going, how it is going over here. to the end where the line click. So this is approximately how you are going to get the the profile of a particular place. So now I am removing them, and I want to extract this elevation here. Maybe I want to produce a topographic map. So all you need to do is to click on the path, and then you can click on this. You see the way this line is being drawn.
Mm.
I can keep on drawing it like this. Now, because of it, the more closer this point are, the more real elevation or how we represent, that's how it's going to look. So because of that, you don't need to be clicking here. Just pin down your mouse and start moving it around that place.
Okay.
So I am pinning down the mouse like this.
Okay.
So you keep on following like this. I want to see the terrain of this place. So I'm just moving, keep pinning down my mouse, and then I'm
Mm.
just moving around here. So with this, it is adding those points there for me. So the closer I have, just like in the normal, the more data you have, the more real-time representation you are going to have. Is that okay?
Yes.
Yeah, so I will keep on drawing this, making sure I have more point around the place of interest. So as many point as you can put, that makes it representing the real life uh,
Oh,
elevation you have here.
okay. Okay,
Okay.
sir.
So because I want to show what the elevation feels like, so that is why I'm taking more time, like I'm adding more point around the place of interest, because I want to see how the elevation is. So this is exactly what I'm doing. So like I said, the more point you have here, the more like the real life experience, like the real life representation of what you're looking for. So I'm just like clicking, and then I am just pinning down my mouse and just hovering it over this particular place which I want to get the elevation. So the more you represent this, the more you have the real, like the way it is looking. Because if you now make, just like you making a topographic map, and you have 10 meters interval, it won't be the same representation if you have 5 meters interval. So you know that 5 meters interval, even though it gives you more point, but it represents it better than what, as in shows it the real way it is on the earth surface. I don't know whether I get what I'm trying to say. Yeah, so I think this is enough for what we are doing. In case you want to do your own, you can do something more clustered, more better than this, right?
Yes.
Yeah, so for this sake, so I'm going on to go ahead and use this. So for me, I'm just using this here to make sure I get the real representation of this place the way it ought to be. So
Okay,
that's
like
why,
did it custard like this?
yeah, so that's why I'm making it more clustered. Why I'm making it more
Mm.
clustered is for me to
Like,
have more points.
okay, we are not going to follow a particular pattern. Like,
Yeah,
it will just be like random.
yeah,
Because
if you want to follow pattern, you can do that later, but it is hard for you to get the pattern. So for me, you can follow a pattern, any pattern you follow. What is important is have a kind of point that will be enough for you to use to extract the elevation point. I don't know what I get what I'm
no,
trying to say. Yes.
okay,
To have more point you want. For me, whether you follow it pattern or not, because
okay,
it might be hard for you to be following paths
yes,
like this. Yeah, people like
Like,
us that doesn't have patience, we want to like follow it anyhow. So far, what we need is having more point over this particular place. Is that okay?
okay,
Yeah. So
yes, sir.
when I am done like this, then what I can do is I will click OK. And this
Okay,
is, yeah, and this is, you can see now, you see what I have done.
okay,
Yeah, the way it have
okay,
followed here.
okay.
You can see it here. Now the next
Yes,
thing I need to do is I will go
right.
down to where I have a kitty here. Is that okay?
Mm,
Here,
yes,
here. Then I'll right click on it and I will save place as.
listen. Eh?
I will click on save place as, and
Okay,
then I'm going to save it anywhere. So I'm putting it in my download and I'm going to click save. So this, I have saved it in a place wherever I want. Then I'll go down to my browser and come to GPS visualizer here. This is the site here, GPS visualizer. It comes up like this, as you see it like this. So I have this interface looking like this. So what I can do is I will go to here where we have look up elevation here. Look up elevation here.
look up, sir.
Then I will click on it, and that is going to open another interface for me. As you can see it here,
Which one?
says
I, I did not. See.
look up elevation
Which
here.
one? Which one?
Look up elevation.
I can look up elevation. Okay,
Did you see it?
okay. Yes, sir.
Now you come down here where you have dem database, digital elevation model database. You see it here?
Yes, sir.
Now look at the matrix, is in matrix meters. Look at the add and convert elevation. Now click on upload file here. Choose a file. Then go to where you download. Where did I download? I downloaded this in Ekiti in download, and it's in Ekiti. And the size is 51 MB. And then I'll click open. And that will be uploaded here. You can see it here. Now, if you look at this, you see that this file is in two formats, either in plain text or in JPEG text.
Okay, for the output.
Yeah,
Okay,
so
for
the
the output.
output, so we can go with any of them. So, but let's leave it by JPEG text, because this will be opportunity for me to show you how you can convert JPEG text on ArcGIS. So
What
when
is
you click,
GPX?
yeah, GPX test, that be GPX test file. So this is also a way
What's
for me.
the
It's a type of data like formats, just like the way you have KML, the way you have shapefile, the way you have test file, the way you have grad file. So it is
yeah,
a GPX file which you are going to convert to layer, either using of any of the software you want.
okay, sir.
Yeah, so now this is the file. The next thing you need to do is to click here, convert and add elevation. So once you click on it, that's going to take, depending on the size of your data, if the size is much, you will know. So here it tells you the content displays within the BB box. So you can look at the content, the way the language is written. Then here, what you just need to do here, your business here is to download this file here. And if you look at the file, it's putting up with the date
Okay,
of the date you are making the conversion. So once you need to do is to click here to download. So you click like this, and that is going to download the file. You can see here it have downloaded it. Now if you go to your download, as you can see here, you see that I have downloaded this here, and this is it right here. So the next thing I need to do is I can go to my ArcGIS. Then conversion tools in Arc Toolbox is here. Or if you don't want to use the conversion tools, you don't know where the GPX file is located in, if you don't know where it is located in ArcGIS, it is always nice that you use the search part where you can search for whatever you are looking for, and that brings it out for you. So you have your conversion tools here, but I'm just saying that if you don't know how to find it, it's always nice you go to search here, wherever you find your search, and type GPX like this and press enter. Then when you
Okay.
press enter, you can see it from conversion tools here. That is ActoBus conversion tools from GPS X to feature. So if you go to toolbox conversion tools, you will see from GPX to uh, you will see it here. Then this is the conversion tools you have here, and you can see
Okay.
from GPS here. If you open it up here, you can see GPX to features. So this is the same
Okay.
thing we have here when you go to this part. So you go down here, you double click on it. Now when you double click on it, you
Mm-hmm.
click here, and that is going to open up for you. So it is requiring you to go to where you save those files. So you remember we downloaded it in, we put it in download, and this is the file here.
Yeah.
I will click on it and I'll click open, and that is going to load the data in here for me. And once it loaded for me, I can define the output where I want it to be outputted. As you can see here, this is the file here, the data.jpegs. This is the output, so I don't worry about where it outputted it, but if I want to change it, I can still change it. So once I am done, I'll click OK. So, and that is, as you can see here, it is making the conversion, and that is exactly what I'm doing. So I wait for it to finish the conversion, and it will add those points for me. Then I can use those points to create any kind of depending on what I want to use. Either I want to do contour, or I want to do whatever. So if you look here, you can see the file I inputted here. Now look at this gap that is here. This was caused here. If you go back to Earth, Google Earth here, you see that here. Let me try to see if I can turn it a bit. So I'm holding, yeah, so I'm going back this way, and then I'm coming here. If you look here critically, or if you look examine here, you see that we don't have much point here the way we have it in the other part. You can see here.
Yeah. Yes.
So this was the reason why this place have a kind of void kind of space in
Okay.
between them.
Wow.
Yeah, because we did not have this cluster point here. And even if you say right click and say profile, you see that here we don't have much data here. You can see.
And can we still add?
Hmm?
Okay, we can still add and we overlay it.
Yeah, we can still add, but if we add, we still need back to make a kind of conversion again.
Yeah. Yes.
Yeah, but
Yes.
you will see the difference here that this will not show us a real representation because we're supposed to have more things here, like this.
Oh,
Yeah, but we didn't have it. So you see now that all things being equal, if I can go back a bit to show you something, let me go back because I want to delete those things that I just added now. And then maybe click OK. And then if you look here, you see that between the length of from here to a place like this is about 300 meters. We did not have anything inside it. This is about 300 meters this way, almost 400 meters. We don't have any point between it. So it means that it won't show us the pure representation of that particular place because you can see the margin we have here. You can see how
okay,
it
sir.
is. So that won't be possible to show us here. So that's why I was telling you the closer you get it, the more better accurate data you're going to have. Is that okay?
Yes, sir.
All right. So we proceed. I just wanted to make sure you understand why there is void here. Now,
I get.
if you open this data here and go to open attribute information, You see that we have this here. We have 3,376 point. And if you scroll here, you see that we have the elevation data here. Can you see it?
Yes, sir.
Yeah, so what next do we need to do? We can add the XY to it. And adding the XY to it, we go down to data management tools here. And then you go to data management tools, you go to features here, you can say add XY coordinate. So if I select the GPX file here and click OK, then it means that I'm going to add XY coordinate, and that will add XY coordinate for me. And that has been added. If I right click here and then open it up and then go down here, you will see the coordinate X, Y, and the Z coordinate. So this can be used for whatever you want to use it for. Either send it
Sorry,
to yeah.
you said that under data management too.
Go to under data management tools here, go to features and say add XY coordinate.
Okay.
So that
All
will
right.
add a coordinate for you.
Okay, sir.
Now let me also show you something going back here. I want to go back a bit backward, and then you see here we have a kitty which I want to add up here. So I want to add a kitty back again, and then I want to make it to output to be the plain text file. If I click on convert, for example, that is going to convert it again for me. You can see the format. This is what I want you to see. You can see the way the format looks like. So now it
Plain.
is, yeah, it is now like a text file. You can see here.
Oh,
So this text file, you can send it to somebody as a test. Like if I
like
done,
Excel.
yeah, like Excel
So
sheet, like a notepad, whichever way somebody can import it then and continue with the work you want to do. Is that okay?
okay, sir.
Yeah. So in this, you don't need to convert from JPEGs to any format, but just use it depending on the approach you want to use. So we are now
Okay.
finally back here. How do we
Yes, sir.
proceed with this? We go to Arc Toolbox, go to Spatial Analysis Tools, and
Special.
yes, Spatial Analysis Tools. I want to do interpolation because I don't know the data here, so I want to fill some places that I don't have as the data. So the best way is to do interpolation. So on this, I'm going to interpolation here under Spatial Analysis Tools, and I'm going to use IDW. So here I can select the GPS file that we have added, and I am going to use the column here elevation or the point Z. If you look at the attribute data here, if you look at the attribute data you have here, you see that you have here as elevation. You can see it here. The same elevation have the same point with Z data. So I can select elevation or Z data. Wherever I want to go is on its own. So I can remove this because raster always have issue with long naming. So I just reduce it a bit. And once
Okay.
I am done, I will click OK. This is now going to make an interpolation for me and give me the places where I don't have data. So it's going to do a kind of feelings for me. Now,
Okay.
if you look at this, you will see this is the way this place are. And this is the interpolation it gave me. It ranges from 420 to 667. Then if I want to visualize the raster well, I can click on image analysis and I will check which of them suit best for it. So, but this is not where we are heading to. So let's go ahead and create contour. So if you look at the contour, if you go down to spatial analysis tools and go to surface here and say contour, then you see that here, if you create contour here and say the contour interval is 1, let's use 1, which I know is going to be very, very clustered. Like it's going to be really, really clustered. Then let's see what 1 give us. You can see what we have here as 1. So this is really, really clustered here, as you can see. Well clustered, and but this actually tried because it shows a very good representation of this particular place.
Mm.
As you can see, but the contour is clustered. So if you look at this, you can take this and let's see where this is actually saved. I think it's in the geodatabase. So for the sake of us making a kind of better preview, I will want to check where it is saved, and it is located in the geodatabase. So I will want to export it to where I want to probably use it for data visualization. Then let me put it here and say a kitty. Then add it up here to the here where we have a kitty here. I want to add it up because I want to copy the location where it is to Google Earth. So I'm going here, right click on it and go to the source, and you can see the directory here. This is where it's located here. From here to here, this is the directory. So I can copy it. I will come back to Google Earth again. Then I will uncheck this. Then look at the same place here. So when I uncheck it, I can click on file and say import, and then I'll paste the location of that file I copied. I will say open, and then I'll add it up here. Then click OK to use a template. Now you can see the elevation, the contour, the way it is. If I want to change the color, I can change the color from what it is, but let me leave it on white, and I'll click OK. Then it will create a kind of Google Earth style templates, and then let it go there. So once this is created, you can see it will move on like this to return back the way it is. So but I have to check this, and you can see the contour coming up here. So we'll wait for it. I think it's loading. So we're able to see the contour of this particular place overlaid on the Google Earth. So you can make your kind of comparison and see that the contour is really matching to what it is. So on that, you check the contour here, and you can see what the contour looks like. So as you can see here, you see that this is actually the way all these places are located. And you remember in contour interpretation, what's how we used to interpret contour. The closer the line, the more steeper slope it is. You know that.
Yes, sir.
Yeah, so with this, you can perfectly create your contour maps. So you can see here, the closer they are here, the more steeper slope it is. You can see it here. So the same thing happened here in on Google Earth. So the slope, the more steeper slope is it, as in the cluster it is, the closer the contour lines, the more steeper slope that particular region is. So if you look here, see that this place, particular place which you have here, is actually having a kind of bigger slope. So with this, so you can successfully extract any point or elevation and then use it to create contour, or have your digital elevation model which you can use for whatever purpose you want to use it. Is that okay?
Yes, sir.
Yeah, so do you have question on this?
I don't have question. I'll do my,
So
but
just
my question, I have a small question.
listen
Like I have a question.
on this.
No. It's not really a deep question. It's just more like those elevation now. Their height above, is it the missing level, or like what's the reference point?
Okay, if you look here, it actually uses, if you read closely here, it actually uses this data here, complete the copies of Nastadem, SRUTM, SRUTM3 so you can see where the data is coming from. Now, if
Okay.
you look at, if you read critically here, You can see every information you need to see about where the data is coming from, because you know about metadata.
Okay.
Yeah, so every data you need here comes in here. You get where they are coming from, because this is the data source where they are, we are getting them from. So you will actually use this to read, to actually know what is the data all about, and how do you come about with this elevation you are having. So but as
Okay.
you can see here, what we are using here is actually the real elevation, which approximate, because it is in meters. And if you look here, it's actually the elevation we are using, like the way it is on the normal earth surface, mean sea level. So you use check this. This is where every information about this particular data we use, the resolution, that's the spatial resolution of the data, and every other information you need to know, because each of them have the like the data source, as you can see here, where they are covered. So if you look here on the map that is plotted here, you can see that Africa is in red, which is around Amsterdam and Nassadam. Then if you go to the Europe, you see Med 1, which you see where it is covered. You see some other places like Russia up here, which is using OODPM. You see here. So if you click here on this, you will be able to see the coverage range of the data you are using. Is that okay?
Yes, sir.
Yeah, so this is, you can see this map. So this is where you have this. The Brazil, Africa are all from here. NASA 1, then United States is NED 1. Some of this is NED 13. The yellow part, I don't know where it is located, but the yellow part is NED 2. SRTM is also this other part.
Okay.
So
What is the confidence interval of this type of thing?
listen.
Like the spatial resolution?
Yeah, the spatial resolution, they varies. That is why they are showing you the source, because some of them have 30 meters, some have nine, some are measured in arc. So different, all of them are having different kind of different spatial resolution. So which, this is Africa. So if you look at it, you will see the spatial resolution of it. Then this is NASA one. When you click on it, it shows you the display, how where they are. And if you want to see the you want to see this a resolution, you can always come. You see that, for example, here this actually capture the spatial resolution, which you can also query on the data. So you see here, they're about, the horizontal resolution is 1 arc second, about 30 meters north to south and 20 meters east to west. And this all, that's what I'm saying, every information, the metadata is all here. Is that okay? That's why it's important when you're looking for a data, you now ask what's the data all about, like have information about the data, so that you will able to know, oh, this is the source of the data, and this is how it was acquired, and this is the resolution. So if you look at here, you can see that the SRTM3 says it includes 90 meters resolution of the entire earth, and
Okay.
then SRTM goes up to 60-degree longitude. But thanks to the effort of the volunteers of Wadaru Panore, the GPS have a polar region covered as well. So you can see this is the spatial resolution as related to NASA. That is SRTM3, which is NASA. Then this one tells you that it is 30 meters resolution. You can see. Then NEP says it is 60 meters resolution. Here, the product is 1 over 3 arc data, and you can see approximately 1 arc. So these are just different, it have it different uh, sources, and then you can go through to get the metadata.
Okay, sir.
Okay, so I think